In this video, we're going to talk about the relationship between force and potential energy and potential energy curves. Okay, to get started though, I want to just give some examples. Actually, let's do this. So, there's a very important relationship between force and potential energy, because potential energy only exists because of the presence of different forces. So, for example, if we have a spring, okay, and it's compressed, let's say it's compressed some distance, so we've compressed this spring a little bit, and there's an object here. This object has potential energy, elastic potential energy, because the spring is compressed. Okay, well, the spring itself is just pushing on the object this way. Okay, and so what I'm trying to point out here is that in order to increase the potential energy, we have to work against this force. Okay, and so anytime you're increasing potential energy, there's some force that's always opposing it, and the reason why is because that force is the reason that we have the potential energy. Another example is that if you're lifting something up, so if we take a box and we lift it into the air, okay, is there a force on the box pointing back down this way that's preventing that from happening? Gravity is. And so we have gravitational potential energy because there's always a force of gravity pointing in that opposite direction. So because of this relationship, or because of that idea, we understand the relationship between force and potential energy to be this. So f of x is equal to the force with respect to distance is equal to the negative derivative of potential energy. Okay? So we can find another relationship from this if we multiply dx to the other side. So we multiply it over and then we can integrate both sides. Okay? And when we do so, on this side we get the change, rather the negative change in potential energy. And on this side we have the integral of f dx. Now, the integral of f dx, we know that to be work, okay? And so we get that work is equal to the negative change in potential energy. Okay, and so this relationship right here and this relationship right here are important for you to remember. Okay, and we'll be using these. Okay, so the next thing we're going to talk about is a potential energy curve. Okay, and that's a graph showing the relationship between potential energy and position. If we were just looking at height off the ground, that curve would look something like this. The higher you get off the ground, the greater your potential energy is. Now, we're going to see a lot of graphs that look kind of like this, and they look kind of like hills or roller coasters, and in my opinion that's the best way to think about them. And so the first thing we're going to talk about is the relationship between this graph and the force acting on an object. Okay, so remember from before that the force is equal to the negative derivative of potential energy. So here we have force as the negative derivative of potential energy, and here's what that means. If we look at the slope of potential energy, we can figure out how strong our force is and in which way it's acting. So for example, in this region right here we have a negative slope. Okay, well, it's a pretty steep slope, which means we have a stronger force, and since it's negative, that means our force is positive. Okay, well, if this way is positive, that means that for this region we have a force that's going to push the particle this way. Okay, and let's go to this region. So for this region right here, we have a positive slope, okay, which means Positive slope would mean negative force, which means the force is going to be pushing an object back this way. Okay, it's going to be pushing it this way for this side, and this way for this side. Same over here. And then here we have a really strong force because it's so steep, pushing back this way. Okay? And then we kind of get some places like right here, and right here, and here, and here, where we'll call equilibrium spots, where there is no force acting because the slope of potential energy is 0. Okay, you can imagine those places kind of like little valleys in a hill where something might come to a rest. Okay, it's going to have a lower energy level at those places. And so the idea here is that these forces are the things that cause it to have potential energy in the first place, and we can kind of see the direction of them. So, and it makes sense a little bit if you think about a roller coaster. So if we're on a roller coaster right here, we're going to get pushed down into this hill. Okay, we're going to come back up the hill, and as we do, we're going to slow down because there's a force pushing us back this way. At the top of the hill, we're going to speed up this way because there's a force pushing us down. And as we come back up, we're going to slow down because that force is pushing us back this way. We get over it, we have a force pushing us here, so we speed up, and then a strong force pushing it back this way, so we slow down, slow down, slow down, and eventually come to a stop right here. Now the reason we stop right here is because this is essentially how much energy we have. We'll call this our energy level. Okay? So let's say their energy level is about 5 joules, which means that we can go to only to places that have 5 joules of potential energy or less. Okay, we're essentially like trapped in this region unless something comes and does work to this object to give it more energy. Okay, so here's another example. We're going to call this a potential energy curve, where potential energy changes according to horizontal displacement. Okay, so we have a little skateboarder sitting right here, and we're going to say their energy level here is 0 because they have no energy. Okay, let's go ahead and give them a little bit of energy. We'll put them right here. Okay, now suddenly they have energy. And this skater, he's going to be trapped in this little potential energy well. Okay, he doesn't have enough energy to get out of it. He only has about this much energy. Now, he has energy to be in a place like this and a place like this, but he doesn't have enough energy to get there because of these potential energy kind of hills in the way. So if I move him though, give him a little bit more energy, maybe put him like right here, now he can actually get over to this region as well. Apparently he likes to jump a little bit too. So now we have the skater kind of trapped in this little potential energy well, but this is his energy level right here. Okay, he doesn't have enough to get up to there or up to there. So we could increase his energy level. Let's go ahead and take him, put him right here. So he's probably going to end up flying off our track though right now. That's okay. Had enough energy to get all the way up to here now. Alright, so anyway, I hope that was a good example and you got the idea from that.